You can build some pretty insane applications using just LLMs, even if you don't really know what you're doing. But what separates a good AI app from a great AI app is one thing, and that's data. Yes, LLMs are good at reasoning, they can do a lot of stuff out of the box, but they get even better and more powerful when you provide them with the correct data and context and useful tools. So that's why in this video, I'm going to show you how to do exactly that. Now, a few weeks ago, Bright Data, a long-term partner of this channel, actually issued me a challenge. They wanted to see the best AI application I could build in just a few days using a ton of their data and APIs. So that's exactly what I did, and that's what I'm going to demo for you in this video, but I'm not only going to show you how it works, I'm going to break down the architecture and walk through step by step exactly how I built this so that you understand how you can do the same. So with that said, let me get into the demo and show you exactly what I made. Now in front of me, I have an AI travel agent built purely in Python that goes beyond the simple use cases that you've probably seen before. I'm not just prompting an LLM and telling it, give me the best itinerary for a trip. This actually uses a ton of data, real-time data as well as historical data to give you relevant replies that are actually real-time. So it can go and look up flight information using things like Google Flights. It can find all of the hotels and their availability, and it can actually use a ton of historical data on restaurants, reviews, and attractions to give you a really contextually relevant response. I'm going to show you how it works, but all of the data for this application does actually come from Bright Data, who did sponsor this video. Now, even if you don't use Bright Data services, you can still create something like this, and I'm going to break down all of the architecture in this video, so make sure you stay tuned. Okay, so let's actually just demo the application. You can see that I have a prompt here. I'm flying from New York to Bangkok on this date and returning on this date. I need a cheap hostel under $20 per night with Wi-Fi, free breakfast, and then some other requirements. I like economy flights with layovers. I want to save money, etc. So as I press plan my trip here, a bunch of things are going to happen. The first thing that happens is it actually goes and parses the information from my prompt or my requirements into information that we can then pass to the model. You'll now notice that it's actually opening up a browser, and the reason it's doing that is because it's automating Google Flights using an AI browser library as well as using Bright Data's automated browser, which you'll see in a second, and it's actually scraping the browser using AI and using LLMs to grab all of the relevant context. So you can see that what it did is it punched in New York to Bangkok and put in the details that we specified, and now it's actually going to the Google Flights site, scraping all of the relevant flights as well as their return flight details, and then it's going to pass it back to an LLM that will parse it for us. I know this is super cool. I'll share with you how I did this in just a few minutes, but I wanted to kind of automate it here or put it locally so you could see exactly what's happening. So anyways, it's going here, it's doing that. Sorry for the quick cut here, but I did want to mention this browser could actually go and book the flights for you as well if you were comfortable giving it access to your credit card, accounts, all of that kind of stuff. I didn't do that for this video just to keep things simple, but you could totally build that. You can see that we kind of get the loading state right here. This does take a second just because I'm doing it locally on my own computer. And then once we have that details, it will go and get flights. It will aggregate these replies. Hang on, I'll show you. So you can see here it found the flight details now, so it just says completed. Now it's searching for all of the hotels. Now it's doing this using something called the SERP API from Bright Data, which I'll show you later. And then it says it's going to put all of this together, so it's going to grab all of this information and then pass it to the LLM and generate our trip. Now the way I've done it is it just puts the trip here in this tab, so you can see that it gives us all of the details like the outbound flight, the return flight, information on pricing as well. So you can see here it tells us the price of the flight. It's in dirhams just because I'm in the UAE right now, so that's why it's giving it to me, the hotel price, the total price, and then it gives us kind of why it recommended a particular hotel and some more information. Now what I've done is I've set up a chat window here where I can just talk about this information, so I can ask it for more details, I can ask it to maybe give me a different hotel, but then more importantly I set up this research tab. Now from here I can ask it a question like, what expensive restaurants should I visit in Bangkok or something? And this is actually a different AI agent, has access to a bunch of tools. It can actually go and search the web using DuckDuckGo search, or it can access, again, that huge data set of restaurants using retrieval augmented generation. So we'll go to the database, really quickly look up a bunch of relevant results, and then it can pass all of the results to the LLM, which can then filter them and give me the response. So you can see here, it says based on the available information, you should go here, 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 here. And if we go back to my VS Code, you can see kind of the reasoning that's going on here, and it will show us actually the tools that it's using. So here's the RAG tool where it's going to the database and pulling information out of our data set. And then it's also using internet search as well and kind of combining those results together, to give us that reply. So there's a bunch of cool stuff that this can do. Obviously, this is just a quick short demo. What I want to do now is hop over to the architecture and explain to you how all of the components work together so you get a sense of how you could build something like this that actually works and is a really cool tool. So I just put together a bit of a diagram here to explain to you everything that's going on because it is a little bit complicated. So let's start here with our travel summary and recommendation. Now, the first thing we need to do for this tool to work is we need to give it some kind of prompt. So if you see here, I have this user input travel requirements. And then after that, what we do is we parse these requirements using an LLM. So just something locally, or we can use like Claude or GPT to get what's known as structured data. So out of LLMs, you can actually grab structured content. And first we need to understand like the check-in, the checkout, so we can then use that later in our API requests. So anyways, we get some trip data parsed into kind of a schema that we want, and I'll show you this in the code later on. And then we have two things that we start running in parallel. We want to start scraping or searching for Google Flights, as well as for hotels data. Now, the idea is that we want to get this information, so real-time data, stuff that's actually relevant, like the flights that are actually available today, not ones that were available many years ago, and then we want to pass that to another LLM, which can then recommend the trip. So within these, let me kind of break down how we actually do this. So when we're looking for Google Flights, the way that I've done this, and there's multiple ways to go about doing it, is I've split it into two components. The first thing that I do is I automate the browser manually using a framework called Playwright. Now, Playwright allows you to do browser automation and press on buttons and fill in fields. So that's what I do to generate the Google Flights page that has like, the destination airport, the origin airport, and the dates that we're going to be traveling on. Now, I combine that with Bright Data's scraping browser, and what this allows me to do is bypass any of the CAPTCHAs, blocks, or IP bands, or mask my location so I can scan for flights in different areas. Now, this scraping browser is essentially a remote browser instance that allows me to, again, get past all of those issues by connecting to a proxy network so that I don't need to do this locally from my own computer. So I essentially send an API request out to Bright Data's scraping browser. It then automates the browser and gives me the URL of that now automated page where I have the details filled in. So you can actually see if we go to Bright Data, this is the scraping browser that I'm using. I can just connect to it literally with a simple WSS string, which I'm going to have to blur out here so you guys don't use my scraping browser instance. And I can kind of view all of the logs and the pricing and all of that kind of stuff here. Anyways, that's the first part. And then what that does is automate the form submission for me. So now I have this Google Flights page. Now, after that, I don't want to have to manually scrape the data from the page because that's really tedious, and I'll have to write a really advanced web scraper and be like, searching through the DOM manually and doing a bunch of stuff that just is really annoying. So instead of that, I'm combining, again, the Bright Data scraping browser with something called browser use. So I just pulled up the page here so you guys can see it, but this is free. You can run it locally. It's open source. It actually outperforms a GPT operator. Now, this is an AI automated browser. It can connect to any LLM that you want, as well as to a remote browser instance. And that's the framework that I was using where you saw kind of all of those boxes and the browser being automated. So you can just run this on your own computer. Or what I actually did, and what I've done in like kind of more production for this application, is I've pushed it out so that it uses the Bright Data browser remotely, so you don't get any CAPTCHAs, blocks, IP bands, all of that stuff that happens when you do a lot of web automation. And we can take advantage of a model to automatically scrape the page for us. So that's kind of what happens. We again use the browser work framework. We use that with Bright Data, and then we connect with an LLM. And then that actually goes, and based on the prompt that I give it, collects all of the information that we're looking for in terms of the outbound flight as well as the return flight, and then gives us that information. So that kind of covers this step right here. And then we have all of this flight data. Okay, the next step is to get the hotel data. Now, what I use for this is the SERP API, or the Search Engine API, which is a really easy way to collect data from search engines. So in this case, we're using Google Hotels, and we go to Google Hotels, or we don't go, but Bright Data goes to Google Hotels, takes our search query, and then grabs the real-time up-to-date information, automatically parses it for us, and then just returns it. So I literally just need to send a simple API request, and then I get all of the real-time hotel data, which I then again pass into the LLM. I'll quickly show you, this is the page for the SERP API if you want to check it out. It works with multiple search engines, not just Google. And if I go to the playground here, you can see we can do like Google Maps, Google Trends, Google Reviews, Google Search, all of that kind of stuff, and you can grab all of those results. So I just use it for hotels, but you can use it for all kinds of pieces of data. And the advantage is you just send an API and then you get all this data back that you can feed into your AI model. So then we come to the recommender LLM. This is just a simple LLM that's set up with a custom prompt where it now takes in this information, the Google flights, the hotel's data. It also takes in our original trip data and the input travel requirements, and then it generates a recommended trip for us. That recommended trip includes the flights and all of the information that I put in the prompt. Okay, so we get this information, our recommended trip. Then what I do is I store this in a chat or memory context. Now for LLMs, you can set up kind of like a conversational buffer memory. That's typically what it's referred to. And you can add additional context to the LLM. So what I do is I take the recommended trip, I put this in kind of a shared memory, and then I have two more agents or LLMs that will have access to this so that they have kind of context on what it is that was just generated and can give me some better responses. So for our travel assistant, this one is quite simple. The travel assistant is just what pops up after you generate the trip. We just take in the context, the user's query, and then we have a response. This one doesn't have access to any tools or anything crazy. It's just another LLM that will give you kind of specific recommendations or allow you to ask questions about the information that was generated from the previous LLM. So just different LLMs for different tasks that have kind of a different objective. That's the idea. Then what I have here is my research assistant. Now the research assistant is a little bit more complicated, and this is what we call a tool calling agent. So rather than being a simple LLM just with a prompt where we inject some data into it, in this case, I actually give the agent access to tools. So we might not necessarily need to automatically pull up restaurants or automatically search something on the internet like we do when we're generating the recommended trip. Like they give a prompt and then we know we need to get flight and hotel data. Here, we don't really know if we need to do this. So what we do instead of automatically doing it is we set up these resources as tools. We then give our agent, which is really running by an LLM, access to these tools. And when the user sends a query, the agent determines what it needs to do and what tools it has access to and can go and use these various tools to generate the response. So for the tools, we have two things. First, our restaurant tool, this again uses a database, specifically a vectorized database or a vector search database. So what I do is I bring in this huge data set from Bright Data, which has like hundreds of thousands of restaurant entries. So actually, let me dive in here and show you the exact data set that I use so you get a sense of what it looks like. Now this is the Google Maps business data set. It has 65 million records. So obviously we don't need all of these because we just want restaurants, and this gives us like all of the businesses. And what you're able to do is you're able to filter this data set with the filters right here. And then you can purchase whatever portion of the data set you want and download it. So in my case, I just got a bunch of the top restaurants. But if you look at it, you can, kind of see an example of an entry. We have name, category, address, phone number, description, open hours, etc. And this data set gets updated every now and then. You can kind of pull the updates and do all of that stuff that you want. So we have a bunch of information here. If we filter by top rated restaurants, you can see it will take a second because it is actually filtering it, and then it will give us all of the restaurants. And that's what I did. I downloaded a bunch of the restaurants and then used that so my AI had access to it in the LLM. Or with the kind of vector search or RAG use case, which I was using there. Now, obviously, there are a ton of data sets here from Bright Data. I just searched Google and you can see a few are popping up. If I get out of the search and we just go back to web data sets, dataset marketplace, you can scroll through and there's like literally hundreds of different data sets with hundreds of millions, if not billions of pieces of data. So pretty much anything you need, you can probably find here. And in my case, again, I was just looking at specifically the Google Maps business one. There's also some cool travel ones here, like hotels listing, Airbnb listing, property information, all of that kind of stuff, if you want more of the historical data. They also have a web archive. So if you want the data that existed previously on the web, you can get that as well. But I didn't end up using that for this project because it wasn't really necessary. Anyways, that's the data set. Now let's go back to the architecture. Then what I did is I vectorized all of this data. So that just means converting it into something that can be searched essentially from your LLM and really quickly in the database. And then I used something called ChromaDB. This is a local vector store database that you can run on your own computer. And with all of these three things combined, so the data set, vectorizing the data, and then throwing it in ChromaDB, I now have a vector database that I can query really quickly and pull out relevant replies. So essentially what the agent will do is when I ask it something, if it needs to use the restaurant tool, it will generate a query string pass that to the restaurant tool. It will really quickly look up all of the relevant restaurants based on that query, pass it back to the LLM, and then the LLM can use that information to generate its response. Now, in addition to that, I also gave it access to a search tool from LangChain, which is DuckDuckGo Search. LangChain is the main kind of engine I'm using in the background to run my various agents, and I'll show you that in the code. So that is how that works. I know that was a lot of stuff, but I wanted to kind of break down the high-level architecture, which I think is the interesting part of this project. Now what I want to do is I want to jump into the code a little bit and just show you some of the main components so you get a sense of how this is structured. And by the way, all of this code will be available from the link in the description. So I'm in the code here, and I'll just really quickly walk you through it in case you want to explore this on your own. So you see that I have two main directories here, front end and back end. Of course, I have some requirements and things that you need to set up the project. Now, if you go to backend, this is where I have a little bit of an API that is just proxying all of the requests to the Bright Data APIs so that they're a little bit more secure. Realistically, this doesn't need to be secure because it's just kind of a demo and it's like a cool project for myself running locally, but I've just used a simple Flask backend here. You can see that I have a few different endpoints that I set up here for things like searching the flights, searching hotels, kind of all of those operations, and polling the result. You can also set up the results to be delivered to you by webhook, but I just went with a simple polling method because I didn't want to deploy this on the internet. Anyways, that's my main kind of app here for my endpoints. And then in here, I have two main things. I have my Google Flights scraper. It's not really a scraper, but that's kind of what I'm calling it. And what this does is, again, those two steps where it goes, automates the browser using Playwright. You can see that I'm connecting to the browser here remotely using that WSS URL from Bright Data. Now, after the connection, I can do some automation of the browser here. So that's what I'm doing, like filling in and selecting the airports, filling in the flight search details. And then at the end, this gives me a URL of that filled in page, which I then pass to the AI browser, and the AI browser does the scraping for me. So I just automate the manual part so it's a little bit faster and we don't need to use the LLM for that. And then the more complex component I push to the LLM. So then we have this where I set up the kind of agentic browser with browser use. I create the agent, the LLM, all of that kind of stuff. Again, right now I did it locally just so you can see what's happening, but you could push this out to a remote browser instance as well. So you can do it at scale and you can spin up tons of browsers and have this working for, a bunch of users, not just one person. So that's kind of the Google Flights. As for the hotels, like I said, it's very straightforward. All we need to do is literally just send a post request to that SERP API with the information that we want. So I just create some query parameters with the data that I want to include for my flight search, pass that here to the SERP API from Bright Data, and then we just set up a simple polling endpoint, again, just to kind of grab the data when it's ready. Again, you can do this via webhook, but I didn't want to set that up here. Then we have all of this stuff. You can see you can specify the occupancy, free cancellation, accommodation type, and you can see I just have like a sample run here, check in, check out, occupancy, all of that kind of stuff. Okay, so that's pretty much the flights. There's a few utilities, and you can see this is the prompt that I'm giving the AI browser in terms of what it needs to actually do and how it should be returning the data to me in a structured format. So that's the back end, and that handles the first kind of parts of our task where we're grabbing that data in real time. And then after that, I just set up some AI agents on my front end. So I used a simple Streamlit front end. If you go to this front end code, you can see this is all written in pure Python, and it uses a library called Streamlit, which is super convenient. And then we have a few of our agent tools here. So if I go to AI, you can see that I have things like some context. So this is a context prompt that we can give to our models. We just have a simple model here. I'm just using Claude 3.5, but you can use really anything that you want. I set up a research assistant. The research assistant uses some local embedding model from Ollama. This is running kind of a local model on my own computer. And then we initialize some of the tools. So you can see we have access to the search tool as well as the restaurant dataset tool or vector index. And then we create the vector store here. Again, bunch of code. I don't want to walk through all of it. And then we have the ability to query where we're just doing a similarity search, pulling the top 10 results, filtering them, and then kind of passing them to the model. And we have a schema. This is what I actually parse the original travel requirements into. So I'm able to, in LangChain, pass this schema to my agent and say, hey, once you get this query from the user, parse it, and I want to have it returned in this format. So that's how I've specified it here, just in a JSON format. We have our travel assistant. The travel assistant, like I said, has some memory. It has access to that context that is kind of that parsed information. And then it just has a prompt that I threw in another model or another file, has a conversation chain so it can remember what you've said, and then it can just give you a response. Okay, we have two more things. We have a travel summary. So this just takes in all of that information from our Google Flights and our Google Hotels, uses a model very simply here. So self.model.invoke. I just have a prompt here. I pass in all of the context and it makes the recommendation based on all of those details. Then I have user preferences, and this is where I set up that simple LangChain model with the structured output, where what it does again is parse using that schema and then give us that data. There's a bunch of other stuff here. For example, if I go into data, you can see actually the JSON file that contains all of our website information. It's kind of too big to format. We have the restaurant database, which is our Chroma vector database. We have some utility files like downloading the dataset via API from BrightData. I have some constants for Streamlit, and then obviously the front-end code. And I just set up a basic API client as well to communicate with my backend. Now look, there's a lot of code here. I can't walk you through all of it. Feel free to download this and mess around with it if you want. It is a super cool project, and if you made it to the end, I hope you found it cool as well. If you guys enjoyed the video, make sure to leave a like, subscribe to the channel, and I will see you in the next one.